All right, folks, here we got the solutions for SAT Math Practice 4. All right, so question 1 gives us the system of equations. It's graphed in the xy plane. What's the x-coordinate of the intersection point, x comma y? So to solve a system, one of the easiest ways to do it is elimination, and that's where you multiply one or both rows by some number in order to make some coefficients be opposites of each other. Now, since I want to solve for x, I want to leave my x's alone, so I need to figure out a way to get rid of the y's. Now, the decimals are kind of confusing, but this looks like 15 and that looks like 5. So let's try this out. So I can multiply everything in this row by 3. When I do that, this turns into a 1.5, and that turns into a 4.8, and that's a negative 3.9. So then when I add my columns down, these y's go away. So this ends up being, I believe, 7.2 x's total. And on the right-hand side, I will have negative 3.6. Now remember, that happens because this gets multiplied by 3, so this becomes a negative 3.9. So 0.3 plus negative 3.9 gives me the negative 3.6. Over here, the 1.6 times 3 becomes 4.8. So 2.4 plus 4.8 is 7.2. So then the last step would be divide everybody by 7.2. And if you do that in your calculator, that'll give you negative 0.5. So there's my correct solution. Alrighty, so let's see here. For number 2, Keith modeled the growth over several hundred years of a tree population by estimating the number of trees pollen grains per square centimeter that were deposited each year within layers of a lake sediment. He estimated there were 310 pollen grains per square centimeter the first year, and the grains were deposited with a 1% annual increase in the number of grains thereafter. Which of the following functions models this? Okay, so the first year is actually t equals 0, because you start time at, because t is measured after the first year, so t0 is the first year. So if I plug 0 into any of these equations, I should get 310. And that actually doesn't happen for these two, so I can eliminate those right away. Now here, population is increasing, so if I plug 1 or 2 into one of these two equations, I just need the one that makes the number go up. It actually ends up being this one. The other way to think about it is with a 1% annual increase. That means it needs to go up by 101%, which is that number right there. Okay, so question 3, based on the equation above, what is the value of 3x minus 2? So there's a couple ways we can approach this problem. If you look, we've got this 9x minus 6 on both sides. So I can actually subtract this entire term across to the right-hand side. So subtract 2/3 9x minus 6 across, which would give me negative 4. That's terrible. Equals 1/3 times 9x minus 6. And if I distribute that 1/3, I get 3x minus 2. So 3x minus 2 is equal to negative 4. Now, the other way to do this would be to distribute this 2/3 across. So make this be, that's going to be 6x minus, 4 minus 4 equals 9x minus 6, and then solve for x. One thing you have to be careful of doing that is if you distribute and then solve for x, you need to remember that the question's asking for what 3x minus 2 is, not what's the value for x. So this would, so that would be careful if you're going to do it that way. Okay, 4, the function f is defined above. If k is a positive integer, which of the following could represent the graph of f of x in the xy plane? So this is what's referred to as a factored form. We have two factors being multiplied together. The trick to this is if I set this equation equal to 0, I can solve for my x's. So this, what number plus 3 is 0? Well, negative 3, which means that one of my solutions has to cross through the x-axis at negative 3, which is a possibility for choice A and for choice D. The other thing is, if I look at this coefficient, that coefficient is positive. There's technically a 1 out front of this first parentheses. That means that this parabola opens upwards, and the only one of these that crosses at negative 3 and opens upwards is this one. If k is a positive number, it just means it's going to cross on the right-hand side, which these both do, so that doesn't provide us any help. So if you notice, these are two actually just mirrors of each other. This one crosses at negative 3 and 2, so does this one, but this one opens down, this one opens up. Okay, number 5, h equals 1.88L plus 3201. So the formula above can be used to approximate the height h in inches of an adult male based on the length L in inches of his femur. So L is how long the upper bone of your leg is. What's the meaning of the 1.88 in this context? Let's see here. the approximate femur length in inches. So that's not right because L, H is the height of the person, L is the length of the femur. So the approximate increase in a man's femur length, no, because it's being multiplied by the length of the femur. So the approximate increase in the man's height for each increase in his femur length. So as L gets bigger, so does his height, which means it must be choice D. All right, question 6. In the quadrilateral above, AD, segment AD, so that's this piece. The symbol means parallel to BC, so these are both parallel to each other. And CD equals 1/2 AB. What is the measure of angle B? So this angle up here. Now the trick to this is we need to think about this in terms of a right triangle. So because now this is a square over here, so that's a 90-degree angle because that's a right angle down here. So if I can figure out what that angle is, I can add it to 90 and get the whole thing. Now if this is 1/2 of that. That makes this a 30, 60, 90 triangle, which means that this is a 60-degree angle. So this does require you know the properties of right triangles, that the short side is half the hypotenuse in a right triangle. So if that's 60 and that's 90, the whole thing is 150. Alrighty, so choice 7. Okay, so these are some free responses because you will see those on the SAT. Lynn has $8 to spend on apples and oranges. Apples cost 65 cents each, and oranges cost 75 cents each. There's no tax, and she buys 5 apples, less the maximum number of whole oranges she can buy. All right, well, we would have to take 65 cents times 5. We'll make that next. To figure out how much she's spending on those apples. So 5 times 65 cents is $3.25. So $3.25 is how much she's spending. So that means out of her $8, if you take off the $3.25, which is how much she's spending on apples, that leaves us $4.75 to spend on the oranges. And if each orange costs 75 cents, if I take $4.75 and I divide by 75 cents, that tells me I get 6.3 decimal place. 3, repeating forever, oranges. Now you have to buy whole oranges, so you can't buy this decimal part, which means at best I can buy 6 oranges, whole oranges. So you can't round up or down or anything. You just have to ignore the decimal place. So 6 oranges are the best I can do. All right, number 8, figure not drawn to scale, which means you can't try to eyeball the angles. So in triangle above, A equals 34 degrees. What's the value of B plus C? Now this problem relies on the fact that in geometry, in a triangle, all 3 angles have to add up to 180 degrees. Now I don't care what B and C are separately, but since the 3 of them have to add up to 180, if I know what A is, I can work out what this has to total to. So I know that angle A plus angle B plus angle C equals 180, but I know that A is 34. So 34 plus B plus C equals 180. Yep. So if I subtract my 34 across, I get B plus C equals whatever 180 minus 34 is, which comes out to be 146. And that's all I can solve that equation, because now I've got 2 variables and I can't solve an equation. But that's what the question is asking. It says, what is B plus C? Well, B plus C is 146. And there's the end of our solutions.